In this session we're going to cover Module 10, Section 2, Process Mapping. So learning objectives for this module, we're going to learn how process mapping fits in with process improvement. We're going to have the overview of the uses of a process map, learn how to build a process map step by step, the difference between a top level map and a detail map. I'm going to complete a process mapping exercise, review some examples of process maps that have already been completed. So process mapping, a process map should describe your major activities or tasks, the sub-processes within those, the process boundaries, top level versus detail, process inputs or your X's, your process step outputs or your Y's, and this should be reviewed frequently and updated. Remember, your outputs are always a function of your inputs. So what is a process map? A process map is a graphical representation of a process flow, identifying the steps of the process, the X's and the Y's of the process, and opportunities for improvement. Process maps need to be modified to fit the particular needs of any specific process. So process maps are hierarchical. The top level flow map, major use for this is to locate critical features or processes. It's usually focused on process sequence for a product. It is characterized by a linear flow from one process step to the next. It follows the process sequence but usually lacks sufficient detail for a new person to successfully complete the task. Now, a detailed process flow map, the major use for this one is to understand details of how a process works. The decision points are usually focused on one or two processes in a work area. It should be used for work instructions. It's also used to develop the FMEA and the control plan. When we're talking FMEA, we're talking failure modes and effects analysis. It is characterized by convoluted decision paths. Following the map should lead to successful completion of the task. So that just iterates that there can be different levels of process maps, and the level that you go in at depends on the purpose of the process map that you're going to be using. So process map has many uses. It provides a step-by-step picture of the as-is situation for discussion and communication. It defines and highlights areas for improvement in a process. There can either be elimination of non-value added steps or addition of needed steps depending on the desired outcome of the process. It documents the hidden factory or the hidden workplace. So process maps can be used on any type of process: manufacturing, design, service, or admin. But always the first step in creating a process map is to have a well-defined problem statement. So make sure you define your problem statement first of all before you go into process mapping. You can help doing this with using 5 Whys, but ultimately you have to define that issue completely and fully. First step, develop an upper level process map. So sometimes you can go up one level from this and use a SIPOC, which would also include, as well as inputs, process and outputs, would include your suppliers and your customers. So identify the major inputs and customer outputs for the suspect process and identify possible connections. Step 2. Identify process step within boundaries. Map the inspection points. So inspection points signaled by a decision diamond. So decision diamonds must pose a question. No exceptions to this rule. They'll remain consistent with mapping alternative paths. An inspection point creates a pass or fail decision based on objective standards. Inspections may lead to a reversal of process flow, rework, or scrap. Specific objective questions are almost always better. So is the pin seated correctly? Does the O-ring function properly? Is the cover aligned correctly? Step 3. List the output variables, or the little y's, for each step for the process and the product. So remember to have a look at how the little y's relate to the big y's, and what if they don't? What's that going to mean for you? List the inputs, or the x's, for each process step. And how do the x's relate to the big y's and small y's? Step 5. Characterize the inputs as noise, SOP, controllable and critical inputs. Your process input variables. So your noise inputs, these are ones that impact the output variables but are difficult, impossible, or we choose not to control. For example, environmental variables such as humidity or temperature. Standard operating procedures, so standard procedure for running the process. Controllable inputs, these are the x's that can be changed to see the effect on the y's, sometimes called knob variables. Your critical inputs, or your x's, these are the things that have been statistically shown to have a major impact on the variability of the outputs. Step 6, we add the operating specifications and process targets for the controllable and critical inputs if they're available. Step 7, identify the steps as value added or non-value added. And this gives us the big picture overview. So the process map will feed cause and effect matrix, which in turn feeds the initial assessment of capabilities and control plans, which in turn feeds the failure modes and effects analysis. So helpful hints on process mapping. Always process map with a team. Rarely does one person have all the process knowledge. Interrogate the process by watching in many different conditions. You must watch the process as it happens to see the detail that you need. Don't let space be an issue. Consider using post-its as the process steps and post on a wall to get your initial ideas across. If your map doesn't have enough space to list all of the information, use numbered reference sheets as attachments. Maintain your process maps with dates and update them as necessary. Use them as a reference, and always use version control on your process maps. So you want a version number, the title of the process, who owns the process, and what date it was created. In summary, we've learned about how process mapping fits in with the process improvement. We've seen an overview of the uses of a process map. We've learned how to build a process map step by step. We've learned the difference between top level and detailed maps. We've completed a process mapping exercise. We've reviewed examples of process maps. References for this material: Visio software, which you can get for any PC, and Business Process Improvement by Harrington H. James.